Assalamu alaikum rahmatullahi wa barakatuh. Students, today we are going to exercise 10.5 of circles. Let us see question number 1. Question number 1 says, in figure 10.36, I'll make a figure. This is A, this point is C, this is D and O, and you have somewhere here B. Then this angle is 60 degree and this angle is 30 degree. Now question says, in this figure A, B and C are 3 points. A, B and C are 3 points on the circle with center O. So A, B and C are 3 points on the circle with center O, such that angle BOC is equal to 30 degree, angle AOB is equal to 60 degree. If D is a point on the circle, other than the arc ABC. Arc ABC is this, so D is a point other than arc. That means D is outside this arc, anywhere on the remaining part of the circle. Find angle ADC. ADC. So you are required to find this angle. Let's see. What is given? A circle with center O. A circle with center O, in which angle AOB is equal to 60 degree and angle BOC or BOC is equal to 30 degree. To find, what you are going to find? You are going to find angle A, D and C. Angle ADC. That's your target. See, what we can do, we have done that in term, I guess it was term 10.6 or so. We know that if the angle subtended by an arc at the center is double the angle subtended by it on any point on the remaining part of the circle. We know that term. So by that term you can use for arc AC, for AC arc, minor arc. For AC min, minor arc AC, you can say if you see like this is an arc, so angle subtended by this arc at the center is this angle. Angle AOC. Angle AOC is twice the angle subtended by it on some other part on the remaining part of the circle. That means angle AOC is twice the angle subtended by the same arc on the remaining part of the circle. That means it's at T. So angle twice angle ATC. Got it? Then, which implies that angle AOC is the combination of angle AOB and angle BOC is equal to twice angle ATC. You know angle AOB is 60 degree, BOC is 30 degree, twice angle ADC. 90 degree is equal to twice angle ADC. Then you can go 2 1s, 2 45s. Therefore, angle ADC is equal to 45 degree. And that's your answer. Make a note. Now let's have the question number 2. It says the chord of a circle is equal to the radius of the circle. A chord of the circle is equal to the radius of the circle. If this is my chord and that's a radius, that's a radius. This is radius as well. It says chord is equal to the radius. That means this is a chord equal to the radius. So in this triangle, there's a formation of a triangle. In this triangle, all three sides are equal. That means this is an equilateral triangle. So let us say this is center O. Let us say our chord is AB. Further it says, find the angle subtended by the chord at a point on the minor arc and also at a point on the major arc. Angle subtended by this chord on the minor arc is this angle. This angle. Angle subtended by the chord on the major arc is this angle. This one. So we are required to find these two angles. Let me name this point as P and this point as Q. So what's given? A circle with center O. A circle with center O. With AB it is chord, with AB it's chord such that AO is equal to OB is equal to AB. This is given because these are radii, two radii, and chord is equal to the radius. That means all three sides are equal. To find, you are going to find angle APB and angle AQB. Solution. Let's see. You know all three sides are equal. It's an equilateral triangle. You know angles in equilateral triangle is 60 degree each. That means this angle is 60 degree. We came to know that this angle is 60 degree. Now if this is 60 degree, AB arc, minor arc, consider AB minor arc, angle subtended by AB minor arc at the center is 60 degrees. So it will be twice the angle subtended by it on the remaining part of the circle. You got it? So first of all we can do that thing. So since AO is equal to OB is equal to AB, this is given, which implies that triangle AOB is an equilateral triangle. Triangle ABC is an equilateral triangle, which implies that angle AOB is equal to 60 degree. Now reason is angles in an equilateral triangle. Now if angle AOB is 60 degree, we can do for consider AB minor arc. Consider AB minor arc since consider AB minor arc for AB minor arc angle AOB, since angle AOB is equal to twice angle AQB. AQB. You can give the reason, angle subtended by an arc at the center is double the angle subtended by it on the remaining part of circle, which implies that angle AOB is 60 degree, twice angle AQB. 2 ones, 2 30s, therefore angle AQB is equal to 30 degrees. So we are done with this angle AQB. Now consider quadrilateral APBQ. If you observe carefully, APBQ is a quadrilateral, and all the vertices of this quadrilateral lie on the circumference of the circle. And we know if the vertices of a quadrilateral lie on the circumference of the circle, that quadrilateral is called a cyclic quadrilateral. So APBQ, all the vertices of this quadrilateral lie on the circumference of the circle. That means this quadrilateral is a cyclic quadrilateral. Consider quadrilateral APBQ. APBQ. Since APBQ is a cyclic quadrilateral. This is a cyclic quadrilateral. Why? All the vertices lie on the circle. Lie on the circle. Now if APBQ is a cyclic quadrilateral, you know the property of a cyclic quadrilateral, that the opposite angles in a cyclic quadrilateral are supplementary. That means this plus this is supplementary. Then, which implies that angle AQB plus angle APB is equal to 180 degree. Opposite angles of a cyclic quadrilateral, which implies that AQB is 30 degree plus angle APB is equal to 180 degree, which implies that angle APB is equal to 180 minus 30 degree, and that is 50 that is 150 degree. Therefore, angle APB is equal to 150 degree. That's it. So these are your two answers. This is one answer and this is another answer. Kindly make a note. Let's have question number next. Question number 3. It says in the figure angle PQR is equal to 100 degree. I'll make a figure. This is center O. PQR is equal to 100 degree. PQR. So it's something like this. Then you have like this. Then like this. This angle is 100 degree. P Q R. Center O. Got it? Angle PQR is equal to 100 degree, where P, Q and R are points on the circle. PQR on the circle. With center O, find angle OPR. OPR. So this is an angle what you are about to find. So what is given? A circle with center O. A circle with center O. A circle with center O in which angle PQR is equal to 100 degree. To find, you are going to find angle OPR. Angle OPR. Let's have a construction this time. What I'll do, I'll take any arbitrary point on this major arc PR. Take some point, say S. Let me take it here. S. Now join PS and SR. take an arbitrary point. Arbitrary means any random point on PR arc major. And hence join PS and RS. By this you came to know one thing, that P, Q, R, S is a cyclic quadrilateral because P, Q, R and S lie on the circumference of the circle. So all the vertices of a quadrilateral, they lie on the circle. If they lie on a circle, it's a cyclic quadrilateral. Since P, Q, R, S is a cyclic quadrilateral, as all the vertices lie on the circle, as all the vertices lie on the circle. One thing. Then, which implies that, then I can say opposite angles are supplementary by the property of a cyclic quadrilateral, which implies that angle PQR plus angle PSR, since it's a cyclic quadrilateral, that means the opposite angles are supplementary, is equal to 180 degree. PQR plus PSR is equal to 180 degree opposite angles of a cyclic quadrilateral. Got it? Then PQR is 100 degree plus PSR, keep it as such, is equal to 180 degree, which implies that angle PSR is equal to 180 degree minus 100 degree. Therefore, angle PSR is equal to 80 degree. Now you came to know one thing, that this angle is 80 degree. This angle is 80 degree now. Now, for major arc PR, for major arc PR, for major arc PR, this arc, well, you see, angle subtended by this arc at the center will be this reflex angle. So, angle POR reflex. Angle POR reflex. It will be twice angle subtended, or you can do one thing. Let me make it easy. I'll consider this arc PR minor arc. Angle subtended by it is this. For PR minor, consider minor P arc. This one, PR minor. Angle subtended by this arc at the center is angle POR. Angle POR, it will be twice angle subtended by it on the remaining part of the circle. That means angle PSR. Angle PSR, which implies that angle POR is equal to twice angle PSR is 80 degree. So that is 160 degree. POR. Therefore, angle POR is equal to 160 degrees. This angle is 160 degree now. You got it? Let's come here. See. Consider triangle OPR. If you observe carefully, triangle OPR, OP is equal to OR. Since OP is equal to OR, why? Radii of the same circle. Radii of the same circle. Which implies that in a triangle, two sides are equal. That means an isosceles triangle. So opposite angles will also be equal. Angle opposite to OP is angle ORP. Angle ORP is equal to OR. Angle opposite to OR, angle OPR. Angle OPR. Angles opposite to equal sides. Now if that's the case, then angle OPR plus angle ORP, OPR plus ORP plus POR is equal to 180 degree. Angle sum of triangle. Got it? Which implies that angle OPR plus, I'll write OPR for ORP because ORP is equal to OPR plus angle POR is 160 degree is equal to 180 degree. Then here twice angle OPR is equal to 180 minus 160 degree, which implies that twice angle OPR is equal to 20 degree. 2 ones, 2 tens. Therefore, angle OPR is equal to 10 degree. Now, what you came to know that angle OPR is equal to 10 degree. OPR is 10 degree, and that's it. And so on, and that's your answer. Make a note. Now let's have the next question, question number 4. Question number 4, you can see question number 4, angle ABC is 69 degree, angle ACB is 31 degree. I'll give you some idea about this. This is A, D, B, C. This whole angle is 69 degree. This small angle is 31 degree. You need to find BDC. BDC. You need to find this angle. What you can do, the question is very easy. What you can do, you can consider first this triangle ABC. Apply the angle sum property ABC. You have one angle, two angle. Apply angle sum property, you'll get this angle. Since you get, the moment you'll get this angle will be equal to this angle because they are the angles in the same segment. Angles in the same segment are equal, you know that. We have proved that. So this angle will be equal to this angle. So the measure of this angle will be the answer of this angle. So that's it. Then the next question says, you have like this, and then this. This angle is 20 degree. This whole angle is 130 degree. It says A, B, C and D are 4 points on the circle. A, B, C, D are the 4 points on the circle. AC and BD intersect at a point E. AC and BD intersect at E such that BC is equal to 130 degree. ECD is equal to 20 degree. Find BAC. BAC, you need to find this angle. Again, it's very easy. What you can do, you consider triangle EDC. EDC. This is an exterior angle of this EDC. Now, exterior angle is equal to sum of two opposite interior angles. So you'll get this angle. Now, this angle is equal to this angle. Angles in the same segment. That's it. Now, let's have the next question. This was 4th and this was 5th. Now let's have question number 6. ABCD is a cyclic quadrilateral whose diagonals intersect at a point E. ABCD is a cyclic quadrilateral. So let me make a cyclic quadrilateral. Let us suppose this is a cyclic quadrilateral whose diagonals intersect at point E. Diagonals intersect at point E. If angle DBC is 70 degree, C and D. If angle DBC is 70 degree, BAC is 30 degree. BAC is 30 degree. Find angle BCD. BCD. You need to find this whole angle. Further, if AB is equal to BC, AB is equal to BC. So this line segment is equal to this. AB is equal to BC. Find angle ECD. 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 So this angle. This angle and this whole angle. Let us see. Give a cyclic quadrilateral, A, B, C, D. A cyclic quadrilateral A, B, C, D in which angle DBC is equal to 70 degree. DBC is equal to 70 degree and angle BAC, yes, and angle BAC is equal to 30 degree and AB is equal to BC. To find, you're going to find you're going to find angle BCD. Angle BCD, yes, BCD and ECD. Angle BCD and angle ECD. Let us see how it works. First of all, we can do one thing. have angle, we can get this angle. First of all, I'll get this angle. See, for consider chord DC. For chord DC, this is 70 degree, angle subtended by this chord. Then this angle will be equal to this angle. You'll get this as 70. Then 70, you will get this here. See, consider, or you can write for chord DC. For chord DC. Since for chord DC, since angle DBC, angle DBC is equal to angle DAC. Why? Because these are angles in the same segment. This segment, angle subtended by the chord, angle subtended by the chord, angles in the same segment, they will be equal. Angles in the same segment. Therefore, angle DAC is equal to DBC is 70 degree. So angle DAC is equal to 70 degree. Now you came to know that this is 70 degree. Now if this is 70 degree, ABCD is a cyclic quadrilateral. Now opposite angles of a cyclic quadrilateral are supplementary. Now angle BAD plus angle BCD is equal to 180 degree angles of a cyclic quadrilateral, which implies that BAD is the combination of angle BAC plus angle DAC. BAD is equal to BAC plus DAC plus BCD. BCD is what we need to find, is equal to 180 degree. Then BAC is 30 degree plus DAC, we just found it, 70 degree plus angle BCD is equal to 180 degree. Then this is 100 plus angle BCD is equal to 180 degree. Then you can solve for BCD easily. 180 minus 100. Therefore, angle BCD is equal to 80 degree. And that's your first answer. BCD is equal to 80 degree. Now you are required to find ECD. Now see, since let's do here. Since AB is equal to BC, it's given, which implies that. Then in triangle ABC, angles opposite to these sides are equal. Angle opposite to AB is angle BCA. Angle or ACB you can write. Angle ACB is equal. Now angle opposite to BC, BC is here. Angle opposite to BC is 30 degree. That means it's BAC. Angle BAC. Angles opposite to equal sides of a triangle. You got it? Now ACB. ACB. Therefore, angle ACB is equal to BAC. We know BAC is 30 degree. That means ACB is 30 degree. Now angle ECD. Angle ECD. ECD is nothing but angle BCD minus angle ACB. This angle is equal to this whole minus this thing. And that will give you BCD. BCD we just found, it's 80 degree. So it's 80 degree minus ACB is 30 degree. 30 degree. Therefore, angle ECD is equal to 80 minus 30, that's 50 degree. That's it, and that's your answer. So we were about to find BCD and ACD. This is your first answer, BCD, and that's BCD. That's the second answer. Make a note. Now let's have question number 7. If diagonals of a cyclic quadrilateral are diameters of the circle through the vertices of the quadrilateral, prove that it's a rectangle. So we have a cyclic quadrilateral. We have a cyclic quadrilateral like this. This is a cyclic quadrilateral, say A, B, C, D. Cyclic quadrilateral because all the vertices of the quadrilateral lie on the circumference of the circle. Now, it says that if diagonals of a cyclic quadrilateral are the diameters of the circle. This is diagonal of a cyclic quadrilateral 1 and this is second. Now it says these two diagonals are the diameters of the circle. If they are diameter of the circle, that means this is the center. Now AC is a diameter, BD is a diameter. Let me name this as O center. You have to prove that ABCD is a rectangle. Now see. What is given? A cyclic quadrilateral ABCD. A cyclic quadrilateral ABCD. Cyclic quadrilateral ABCD with where its diagonals where AC and BD are the diameters of a circle. To prove, what we have to prove? We have to prove ABCD is a rectangle. ABCD is a rectangle. Now let us try to prove it. ABCD is a rectangle. First of all, we know that ABCD is a cyclic quadrilateral. That means you know the property of a cyclic quadrilateral, that opposite angles are supplementary. So this angle plus this angle is 180 degree. Or you can go directly like this. This will be easy. Consider chord BD. Consider chord BD. Now for chord BD, BD is a chord because since it's a diameter, diameter is also a chord. Now BD is a chord. Now angle subtended by this chord is the angle subtended in a semicircle, and you know angle subtended in a semicircle is 90 degree. We have proved that now. Consider chord BD since angle BAD angle BAD is, or you can write directly, is equal to 90 degree. Your reason, angle subtended in a semicircle. In a semicircle, because diameter divides the circle into two semicircles. So angle BAD is equal to 90 degree. BAD is 90 degree. Similarly, for chord BD, this angle is 90 degree. For chord BD, this angle is 90 degree. And for chord BD, that is also the angle subtended in the semicircle. For chord BD, angle BCD is equal to 90 degree. Similarly, for chord AC, angle subtended in a semicircle, this angle is also 90 degree. Similarly, for chord AC, angle ADC is equal to angle ABC. Because AC is a chord, now angle subtended by this chord in the semicircle is 90 degree. Angle subtended by the same chord in this semicircle is 90 degrees. So angle ADC is equal to angle ABC is equal to 90 degree. Now what you observe, all the four angles of this quadrilateral is 90 degree. That means it's a rectangle. Then angle BAD is equal to angle BCD is equal to angle ADC is equal to angle ABC is equal to 90 degree. Therefore, ABCD is a rectangle. Hence, proved. Quadrilateral demonstrandum, then make a note. Now let's have the next question. Question number 8. It says, if the non-parallel sides of a trapezium are equal, prove that it's a cyclic. You have a trapezium and question says, if the non-parallel sides of a trapezium, so that means this and this, are equal, then prove that it's a cyclic. Let me name this A, B, C, D. So what's given? A trapezium ABCD in which AD is equal to BC. AD is equal to BC. To prove. What we have to prove? We have to prove ABCD is a cyclic quadrilateral. ABCD is cyclic. Let's have a bit construction. How we can prove that this is cyclic? When we will be able to prove that the opposite angles are supplementary. If opposite angles are supplementary, one of the pair of opposite angles is supplementary, that means it's a cyclic quadrilateral. So all you need to do is just prove angle A plus angle C is equal to 180, or you can prove angle B plus angle D is equal to 180. Let's do a construction. What I'll do, I'll from B draw a line From B, draw a line parallel to AD. So from B, draw a line parallel to AD. Intersecting the extension of DC at some point, say X. From B, draw a line parallel to AD, intersecting the extension of DC at X. So from here you are drawing a line parallel to this side, which is intersecting the extension of DC at X. Okay. Let's have the proof. Let me name these angles. Or first of all, we can do one thing. Since AD is parallel to BX, AD is parallel to BX by construction. We just constructed it. And AB is parallel to DX as AB is parallel to DC. AB is parallel to DC because it's a trapezium, and DX is nothing but extension of DC. So AB will be parallel to DX as well. AB is parallel to DX. Now from this and this, what you get? Which implies that AB is parallel to DX and AD is parallel to BX. And that means both the opposite pairs are parallel. That means ABXD is a parallelogram. So ABXD is a parallelogram. Then if ABXD is a parallelogram, ABXD is a parallelogram. That means opposite sides will be equal. So AD is equal to BX, which implies that AD is equal to BX. Opposite sides of a parallelogram. However, but if you see, it's given that AD is equal to BC. However, AD is equal to BC. It's given. Now if AD is equal to BX, AD is equal to BC. That means BX is equal to BC. Which implies that BC is equal to BX. Now BC is equal to BX. If BC is equal to BX, that means BCX is an isosceles triangle with two sides equal. Then angles opposite to these two sides will be equal. Which implies that, now angle opposite to BC opposite angle is this. It will be equal to angle opposite to BX. That means that is this angle. So BC opposite angle is BXC. Let me name this angle as, say, or just write it. BC, angle opposite to BC is angle BXC. BXC. Angle opposite to BC is BXC. Yes. Angle opposite to BX is BCX. Reason angle BCX, angle BXC is equal to angle BCX. Angles opposite to equal sides of a triangle. Now BXC is equal to BXC. This angle is equal to this angle. But ABXD is a parallelogram. Or first you can do one thing. Now this angle plus this angle. Now angle ADX. Let me name this angle 1. It will be easy to do. Name this angle 1, 2, name this angle 3. Name this angle 4 and this angle 5. Now here you can do BXC. BXC is angle 1. Therefore, angle 1 is equal to BCX, that's angle 2. Okay. Angle 1 is equal to angle 2 now. Now, angle 3, angle 1 plus angle 3. Angle 1 plus angle 3 is 180 degree. Why? Because these are adjacent angles of a parallelogram. Adjacent angles of a parallelogram. Because we just proved that ABXD is a parallelogram, that means adjacent angles of this parallelogram will be supplementary. So angle 1 plus 3 is equal to 1 plus 3 is 180 degree. Then we can come here. After that, we can make one more thing, that is 1 plus 3. 1 plus 3 is 180. And I can say 1 plus 3, 2 plus 4, 1 plus 4. And angle 2 plus angle 4. Angle 2 plus angle 4. This is also 180 degree. Why? It's linear pair axiom. LPA. Straight line. Ray intersects these two angles. This ray intersects this line segment, and the angles so formed are supplementary. That's called linear pair axiom. So angle 2 plus angle 4 is also 180 degree. Now 1 plus 3, then 1 plus 3 is 180. 2 plus 4 is also 180. 1 plus 3, 180. 2 plus 4 is 180. So that means 1 plus 3 is equal to 2 plus 4. Is equal to angle 2 plus angle 4. 1 plus 3 is equal to 1 plus 4. Good. Now you can make one substitution. 1 plus 3 is equal to 2 plus 4. I can write 1. In place of 1, I can write 5, because these are opposite angles of a parallelogram, that will be equal. So angle 1 is equal to angle 5. So angle 3, keep it as such, angle 3 plus angle 3 is equal to angle 2. I can write angle 2 as angle, no sorry, do one thing. Keep angle 1 as such, then in place of angle 3, you can write angle 1 plus angle 3 is equal to angle 2, you can write angle 1, then plus in place of angle 4, you can write, no, it will not work like this. We can do one thing, angle 1 plus angle 3 is equal to angle 2 plus angle 4. Let me make it easier. I can do one thing. Angle 1 plus angle 3 is 180 degree. This plus this is 180 degree. And angle 1 is equal to angle 5. Angle 1 is equal to angle 5. Opposite angles of a parallelogram. Opposite angles of a parallelogram. Angle 1 is equal to angle 5. That means you can say angle 1 is also equal to angle 2. That means you can say angle 2 is equal to angle 5. Got it? Because angle 1 is equal to angle 2. If angle 1 is equal to angle 5, that means angle 2 is equal to angle 5. Now angle 2 is equal to angle 5. But I can say one thing. Angle 2 is nothing but 180 minus 4. Angle 2 is 180 minus 4. Angle 2 is 180 minus 4 is equal to angle 5. Why? Because angle 2 plus angle 4 is 180 degree. That is linear pair. Angle 2 plus angle 4 is 180. So if I find angle 2 here, that will give me 180 minus 4. Angle 2 is equal to 180 minus 4. So angle 2, I replaced it with 180 minus 4 is equal to angle 5. And 180 is equal to angle 5. You can transpose this, that is angle 4. So which implies that angle 4 plus angle 5 is equal to 180 degree. Now angle 4 plus angle 5. These are the opposite angles of our previous A, B, C, D. I just told you that if you will be able to prove that the opposite angles, one of the pair of opposite angles of a cycle of a quadrilateral is supplementary, that means it's a cyclic quadrilateral. So 4 plus 5 is 180 degree. Therefore, ABCD is a cyclic quadrilateral. Why? Because opposite angles are supplementary. Opposite angles are supplementary. That's it. ABCD is cyclic, so hence proved. There is no need to write this line. 1 plus 3 is because it just worked directly now. Angle 1 is equal to angle 2. Then we used angle 1 is equal to angle 5, opposite angles of a parallelogram. Okay, make a note. Now we have question number 9. Two circles intersect at 2 points. Two circles intersect at 2 points B and C. So we have one circle. We have another circle. These two circles meet at B and C. So let's say this is B and let's say this is C. Through B, two line segments ABD. Through B, there runs a line segment ABD. Just like this. Like this. Through B there runs another line segment PBQ. PBQ. intersect circle at ADPQ. So these two lines if intersect circle at APQD. Prove that angle ACP ACP is this angle. So you have to prove this angle is equal to QCD. QCD. You need to prove this angle is equal to this angle. That's our question. Let us see. Given is two circles intersect each other at B and C. B and C. Yes. Such that ABD and PBQ are two line segments. What you are going to prove? We are going to prove angle ACP is equal to angle QCD. Let us do a bit construction. What I'll do, let me join this AP. Join this DQ as well. Join AP and DQ. Join AP and DQ. Yes. Now let's see. For chord AP, what you observe? You observe angle subtended by this AP is angle ACP, and also angle subtended by this AP on the on the arc this AP of the bigger circle, that is ABP. So this angle is equal to this angle. Got it? Consider chord AP. Consider chord AP, since angle ACP is equal to angle ACP is equal to angle ABP. ACP is equal to angle ABP. Reason? Angle subtended in the same segment. Similarly, you can do similarly for chord DQ. What you observe for DQ? Angle subtended by this DQ is QCD. Angle QCD is equal to this one, this angle. Angle DBQ. However, if you see, angle ABP is equal to angle DBQ. ABP is equal to DBQ. Why? Because ABD and PBQ are straight lines. These are line segments. Now these are vertically opposite angles. Very good. Vertically opposite angles. If that's the case, so ACB is equal to ABP and QCD is also equal to ABP because DBQ is equal to ABP. Therefore, you can say angle ACB is equal to angle QCD. Hence, that's it. Hence, proved. Quod erat demonstrandum. Kindly make a note. Then you have question number 10. If circles are drawn taking two sides of a triangle as diameters, prove that the point of intersection of these circles lie on the third side. You can do it easily by the construction, or you can use the rule of angles subtended in a semicircle. You can go it by the method of contradiction. You can say that let us assume that this point of intersection does not lie on the third side. It lies it lies on a plane other than the third side. Then you can make that assumption, but ultimately what you will get your assumption as wrong, because angle subtended in a semicircle is 90 degree. You'll get 90 plus 90, 180. That's a straight line, so your assumption will be wrong, and hence it lies on the third side. Then you have question number 11. ABC and ADC are two right triangles with common hypotenuse AB. Prove that angle CAD is equal to CBD. I'll give you some hint about this. ABC and ADC are two right triangles with common hypotenuse AC. So it's like this. ABC ABC common hypotenuse AC. Then you have ADC. So it's like this. ADC. ABC and ADC, two right triangles with common hypotenuse AC. Common hypotenuse AC. Prove that angle CAD, CAD, this angle is equal to CBD. CBD. So you are to join this CBD. CAD, sorry, this angle CAD is equal to CBD, this angle. Now what you can do, this is 90 degree, this is 90 degree, so opposite angles are supplementary. That means it's a cyclic quadrilateral. If this is a cyclic quadrilateral for chord, now this is a cyclic quadrilateral. So for chord CD, this angle and this angle are angles subtended by the chord CD, and these are in the same segment, and hence they are equal, hence true. Then you have the last one. Prove that a cyclic parallelogram is a rectangle. Cyclic parallelogram is a rectangle. If there is a cyclic parallelogram, suppose this is ABCD, cyclic parallelogram, and you need to prove that this cyclic parallelogram is a rectangle. All you need to do is just prove one of the interior angles of this rectangle is 90 degree. Since it is a parallelogram in the first place, you need to prove that one of the interior angles of this parallelogram is 90 degree. If that is the case, then it's a rectangle, sorry. What you will do, this is a parallelogram and this angle is equal to this angle. Now angle A is equal to angle C, opposite angles of a parallelogram. But angle A plus angle C is equal to 180 degree. Why? Because opposite angles of a cyclic quadrilateral or a cyclic parallelogram. That means you'll get angle A plus angle A is equal to 180 degree. That will give you twice angle A is equal to 180 degree. That will give you angle A is equal to 90 degree. So angle A is equal to 90 degree. Since one of the interior angles of a parallelogram is right angle, that means it's a rectangle. In a parallelogram, if one of the interior angles is 90 degree, it's a rectangle. So that's it. Make a note. Assalamu alaikum wa rahmatullah.